Medical Watch, the connection between herpes and cancer.
Medical reporter Dina Baer has the latest findings.
It causes cold sores and fever blisters, and it may hold the key to understanding cancer. A local scientist has spent 30 years studying the virus, estimated to affect 80% of the global population. Now he and his team say their findings may apply to another disease impacting millions. They work in concert. The scientists in this UIC lab found a sort of tipping point in a common virus. Dr. Deepak Shukla leads the charge.
I think the imaging will look interesting, I think.
It's this colorful image that highlights their work.
The green is our virus. You see the little green dot here? That's our virus.
The virus is herpes simplex 1.
Virus per se is a quiet virus. It just quietly likes to live in our neurons.
Herpes hides in the trigeminal nerves that stretch to the eyes, nose, and mouth, where it commonly produces a cold sore or fever blister. It's spread through tears and saliva. Stress and a compromised immune system can reactivate the virus.
So there is a constant battle going on between the virus trying to replicate in our neurons and host system trying to suppress it.
To determine the impact herpes makes when it spreads from the eyes or nose, the team injected the virus directly into the nasal cavity of mice.
The virus caused havoc in their brain, killed or inflamed a bunch of their neurons, and there could be all kinds of different neurons.
The herpes virus impact on the brain changed the animal's behavior. The mice were anxious and experienced motor impairment and cognitive issues.
What we showed with mouse is an extreme possibility, but over time, since virus is hiding in our neurons and it's periodically reactivating, something similar could happen in humans too.
A specific enzyme called heparinase, shown here in red, played a critical role in inducing damage in the brain.
So what you're seeing red is huge amount of red. Normally you won't see so much red, and that is an inflammatory signal as well.
It's the same enzyme known to increase in different forms of cancer.
Not just simple cancer, but these are metastatic forms of cancer. So all metastatic, virtually all of them, majority of them, they have higher heparinase.
Heparinase protects cells from dying, a good thing in healthy cells. But when a cell is infected, it too wants to live. That's where heparinase and herpes appear to work together to promote spread. The same might be true in cancer cells. When heparinase wasn't present,
animals that didn't make heparinase at all, they were fine. They didn't develop all kinds of neurological issues, cognitive issues, motor issues. Same amount of virus.
Dr. Shukla says the ultimate goal is to teach heparinase the difference between good and bad cells.
Might prevent a lot of these issues down the road.
The next step is to develop non-toxic heparinase inhibitor they can test in animals and ultimately humans. Back to you.